Welcome back for part 3 of the summer packet. This is the third video, but we are actually on part 4, right? Part 4. Question number 1, sketching a complete graph. This is a quadratic. What I like to do for quadratics is factor them. So this factors into x minus 4 and x plus 1, which gives me a 0 at negative 1 and also at positive 4. That also puts my axis of symmetry right in between them at 1.5, right? 4 plus negative 1 is 3, half of 3 is 1/2. So let me draw the dotted line there. Whoops, I'm going to 2.5 at 1.5. There's my axis of symmetry. To find my vertex, I know that 1.5 or 3/2 is the point in question here, so 3/2 squared is 9/4. 9/4 minus 3 times 3/2 is 9/2, or 18/4. Minus 4 is the same as 16/4. So what do we have here? 9 minus 18 is negative 9, minus 16 is negative 25. So negative 25/4, which is negative 6 1/4. 6, 7, so 6 1/4 is roughly around there. So we can create our parabola at this point with those 3 very important points. And of course we also know that negative 4 is our y-intercept. 0, negative 4. Here I have negative 1, 0, and 4, 0. Alright, let's look at problem 2 now. Sketch a complete graph. So again, I'm factoring into x minus 4, x minus 2, which gives us 4, 0, and 2, 0. 0, 8 is an intercept. I'm going to find my vertex a little differently. I'm going to do the opposite of b over 2a this time. X equals the opposite of b over 2a gives me 3. So that is my axis of symmetry, as well as the x-coordinate of my vertex. Plug in a 3 because it's a nice number. I'm plugging in here. I get negative 1 and 1, so that gives me negative 1 times 1. So what are we looking at here? We have 2 and 4. And we have 3, negative 1. And there we, whoa, that was a bad one there. Let's make it a little more parabolic. And there we go, and that's an 8 there for our intercept. So there are 2 of them. Let's move on to the next page. We're on page 6 here already of our summer packet, halfway through once we complete this page. Again, a parabola, so we're looking at x minus 3 quantity squared. Okay, so we have 3 as our guy here. This is a positive quadratic, so it opens up. X-intercepts are 3, 0. The y-intercept, I think we know, is 0, 9. The vertex is actually right here. 3, 0, and the axis of symmetry is 3. So in this case, we're going to need to use a mirroring point. So we went left 3 and up 9. I'm going to go right 3 and up 9. So there is our third point. We know parabolas are perfectly symmetrical about their axis of symmetry, right? The axis of symmetry, I did not draw it in here, but that is right here. If I fold it over that, these points should fold onto themselves if we're using graph paper. Not the ideal situation here, but you get the idea. Solve each equation for x. I'm going to subtract 110 here and see if we can turn this into a factoring problem. If not, we're going to have to use the quadratic formula. Off the top of my head, yeah, we can factor this guy, 10 and 11, right? X minus 11 and x plus 10. So our solutions are x equals negative 10 and positive 11. Don't think we're going to be as lucky here, but won't know unless we try it. 5 and 1, hey, we are minus and a minus. Right, two minuses make a positive, and two minuses add to a negative. There's negative 5 and negative 3 make negative x. So we get x equals, remember we had to zero these out, 3x minus 5 equals 0, which means x equals 5/3. Add 5, divide by 3. And this one, obviously, x minus 1 equals 0, which means x equals 1. And here, we are not able to factor, so quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4, the a term is 1, the c term is negative 1, all over 2 times the a term. Negative 1 plus or minus the square root of, what do we have there? That's positive 4, isn't it? All over 2. So this is actually working out here kind of nicely. We have negative 1 plus or minus 2 over 2, which gives us either one of two options, negative 1 plus 2 over 2 or negative 1 minus 2 over 2, in which case we get 1/2. And here we get negative 3/2. Negative 3/2 and 1/2. So there we go there. Determine a quadratic equation that has 7 and negative 4 as roots. Well, what we just saw up here, we found the roots up here. Right? Negative 10 and 11 came from x minus 11 and x plus 10. So that means 7 and negative 4 are going to come from x minus 7 and x plus 4, which means if I distribute them through, I get x squared minus 7x and a plus 4x makes a minus 3x, and then multiply, we get negative 28. Is 4 plus root 3 as a root? Well, if it has 4 plus root 3, that also means it has 4 minus root 3. Now dig back into your Algebra 2 archives, something called the sums and the products. If you do not remember it, don't worry, we will cover it this year at some point. So if I add these two together, I get 8. If I multiply them together, think about this, 4 plus root 3 and 4 minus root 3 is kind of like a difference of squares, right? Our middle terms cancel out. I get 16. The positive 4 root 3 and the negative 4 root 3 are gone. Ended up with a minus 3. So I get 13. Well, the sums and products rule is so nice because it's simply x squared minus your sum times x plus the product. And there's our quadratic. Much like complex numbers, irrationals also come in pairs. And we can use our sums and our products here as well. So we get 6. And the product here is going to be, think about it again, so you get 9, 3i and negative 3i cancel out, we're left with a negative I squared. Well, I squared is negative 1, so minus a negative 1 is really a 10. X squared minus the sums times x plus the product. Alright, we're about 10 minutes into this. I'm going to flip to the next page and we'll decide then and there if we want to continue on in this one video. Nope, brand new spanking stuff here. It's exponents, so I want to save that for a new video. And we'll call this one done for now. See you at part 5 on the flip side.